Hello and welcome to the final tutorial of this section on deep neuroevolution, and now we're about to tackle our last evolution strategy, which is called the OpenAI evolution strategy. So first thing first, what you have to understand is that the OpenAI evolution strategy is still a natural evolution strategy as we saw before. That natural evolution strategies section is about these evolution strategies where you have what we call the gradient step, where we update the theta parameters of, in our case, mu and sigma through the gradient of the objective function, which is basically the total score f over our current generation, and in our case of the full world model, the total expected cumulative reward. And that gradient step is also called the update rule, and we're going to see that the particularity of the OpenAI evolution strategy is on that update rule, and you're going to see that that particularity is pretty amazing. But first, let's clearly remind that in the OpenAI evolution strategy, well, the standard deviation sigma is fixed, as we can clearly see it here in the simulation. The blue sampled points are surrounding the mean in green, the green point in a common range, in the same range around the mean. So clearly the standard deviation is fixed, and only, of course, the mean is updated over the generations. But you can also have actually the OpenAI evolution strategy combined to a varying standard deviation, but that's not the particularity of the OpenAI ES. The particularity is the following, is that it proposed a modification of the update rule, exactly that update here with the gradient, that is, wait for it, suitable for parallel computation. And now you can start to guess that it is going super efficient for the case where we have tons of parameters to optimize, because thanks to the parallel computation across different worker machines, well, that evolution strategy technique can optimize a huge amount of parameters. You will have many different machines like Amazon EC2 instances, which will each update a set of parameters among the huge amount of parameters to optimize, and each will follow the natural evolution strategy technique that we explain here with, for example, the PEPG, with that update rule through the gradient step to update the parameters theta in order to increase the objective function j of theta, and in the end to maximize it. But since now you're going to have several and actually many worker machines doing this, well, with this evolution strategy technique, you are able to solve a very complex AI problem. And speaking of very complex AI problems, well, one of the most complex and most challenging problem in AI is the Mujoko humanoid, when you have to train a humanoid robot on how to walk across a field. I actually tried many times to solve this challenge. It is super challenging, and actually this is not a surprise that I had so much trouble. It's because we indeed need many Amazon EC2 instances, so you need kind of a computer lab to solve that challenge. But thanks to the OpenAI evolution strategy, where they used 1,440 workers on these Amazon EC2 instances, well, they were able to solve the Mujoko humanoid walking task in 10 minutes, approximately 10 minutes. And that's something you can only do with the OpenAI evolution strategy with many worker machines. So that's what you need to know about this evolution strategy, the OpenAI one. You will only use it for the most complex tasks in artificial intelligence, like the humanoid challenge, and this is something we definitely don't need for our full world model. But in case you want to play with the humanoid challenge, well, you have it in the master toolkit. It is actually right here, the OpenES evolution strategy. You have it implemented from scratch, and as I told you it is a natural evolution strategy because you're going to use an optimizer here, the atom optimizer, to do that update rule and update the parameter theta composed of mu and sigma in the direction of increasing objective function, that we want to maximize in the end. And so you have it implemented from scratch with, again, the same common process among our ES optimizers with the ask method, the tell method, the current param method, which returns the current parameters, best param method, which returns the best set of optimized parameters obtained at a certain iteration, and the same other methods. So, well, I would be super impressed if one of you showed me the result of something you made with that OpenES evolution strategy, and I would be even more impressed if one of you smashes the Mujoko Humanoid Challenge. Well, that would be amazing to share, but no worries if you have trouble solving it. The best AI researchers in the world today are working on it, and I actually talked with one of them recently. There is one humanoid challenge that hasn't been solved yet. It is called the humanoid flagrant harder in the PyBullet environment, and of course the OpenAI evolution strategy was tried, but no one was able to get some positive results on this challenge. So clearly we are at the state of the art here, but at least you have it, and I'll show you how to plug it if needed to the full world model, even if this is absolutely not necessary. Alright, and so that's the end of this step 10 on deep neuroevolution. Now it is time for the very exciting step, the final run, where we're going to race our AI at that car racing game. So exactly as in the first tutorial of this course, the AI is going to race first for 30 seconds, then we, representing human intelligence, will race as well for the exact same amount of time, 30 seconds, or more precisely 900 steps, and we'll see in the end who gets the best score. But before we do all this, we'll have to do the boring stuff, which will be to, of course, obviously, to install all the packages that we'll need to run all these models. I will also share with you the whole code, and we'll go through it to first connect everything and mostly to see where what we implemented for the VAE and the MDN RNN takes place in the whole full world model. And then the very last tutorial of this course will be, of course, the race. I can't wait to do this. I hope one of you will be able to beat the AI and honor human intelligence. It is one of our last chance to honor human intelligence versus artificial intelligence. Indeed, AI is beating us more and more at more and more games like chess, and then recently the game of Go, and now car racing. Well, what is the world becoming? So, let's honor one last time human intelligence over the car racing game. I'll do my best to try to beat it. I'll actually give myself 5 times to beat the AI at car racing, so you might see a tutorial where I beat the AI. I will practice for sure, you will practice as well, and don't hesitate to share your final score at the end of the course. So I'll see you soon for the race, and until then, enjoy AI.